We're asked to evaluate this sum. So in case this is your first time seeing factorial, if you have a number 5 factorial, that means 5 times 4 times 3 times 2 times 1, like that. Okay, so to evaluate a series like this, you can, if the numbers are small here, you can go term by term. What this says is plug in k equals 2 into your formula. Then add in what happens when you plug in k equals 3, the next one up. Then k equals 4, then k equals 5 is the last one we're going to plug in. Then we're going to add them all up. So here's what it looks like when we plug in all the numbers. There's k equals 2. Now we need to plug in k equals 3. Now we need to plug in k equals 4. It's a negative, sorry. That's a negative 3 over k squared, k to the factorial. And then we need to plug in k equals 5. There we go. We've plugged everything in. Now we just need to add these fractions up. So we could change it all. Adding a negative just means subtracting. That makes it a little simpler. In this first one, 2 factorial means I do 2 times 1. You just keep multiplying all the numbers as you descend. So this is negative 3 over 2. And this next one, 3 factorial, that's 3 times 2 times 1, so that's 6. So that's negative 3 over 6, which is 1/2. That's a little simpler, right? There's a simpler fraction. And then over here, this is negative 3 over 4 factorial. So 4 times 3 is 12. 12 times 2 is 24. And then while we're here, why don't we just simplify this too? The top and the bottom can be divided by 3. So this is a 1. And that's a 3 here. And the last one, I think I did it as an example. 5 factorial, that's 5 times 4 times 3 times 2 times 1. So that's 120. Divide the top and the bottom by 3 again, so that's 1 over 40, I think. Okay, so that's, once we conduct this fraction subtraction, then we're done. It's just an ugly one because we need common denominators. The 40 and the 3 I think are going to be the hardest. So one quick trick to see if something's divisible by 3 is to add the digits. 4 plus 0 makes 4. 4 isn't divisible by 3, so 40 is not. So if we go to the next higher, we can multiply the top and the bottom by 2. 80 is also not going to be divisible by 3 because 8 plus 0 makes 8. So 120 is the smallest number that's going to be divisible by 3. So I'm going to multiply the top and the bottom of this one by 3 so that I have 120 in the bottom. And this one, it's by 40, right? 120 divided by 3. Yeah, so multiply the top and the bottom of this one by 40. While we're here, these already have common denominators. Negative 3 halves subtracted by 1 half makes negative 4 halves, which is just negative 2, right? So this is negative 2. So we can subtract these now. They have common denominators. So negative 40 subtracted by 3 makes negative 43 over 120. But then we still need common denominators to combine these. You could say it's negative 2 and 43 120ths at this point too, but I think they want it as an improper fraction. So I'll multiply the top and the bottom of this fraction by 120. That's negative 240 over 120 minus 43 over 120. So that's negative 283 over 120. And then can we simplify? Probably. If I do that trick where I add the digits, it's not divisible by 3. Let's look at the decimal. That definitely looks like something we could simplify. So 283, I don't know. Maybe by 7? No. By 13? No, that won't work. Okay, let me pause and think about if we can simplify that. Whoops, so up here when I simplify this fraction, that's negative 3 over 4 times 3 times 2. Negative 3 over 24, that should be negative 1 over 8. Oops, negative 1 over 8. So I guess I better go back to school. So smaller number there, 8 seconds, 40. So we can multiply the top and the bottom by 5. So this would be negative 5 over 40, and this is 1 over 40. So that gives us negative 2 subtracted by 6 over 40. So that simplifies to 3 over 20. And here, that's 40 plus, so it's negative 43 over 20. So I just made a mistake simplifying a fraction right here.